Today we're going to talk about how to model quadratics given a situation with the equation being in graphing form of a quadratic. So for this example, we have a fireboat in the harbor is helping put out a fire in a warehouse on the pier. The distance from the barrel of the water cannon to the roof of the warehouse is 120 feet, and the water shoots up 50 feet above the barrel of the water cannon. So before we start this problem, let's go ahead and draw a scenario of what is going on. So we have a boat that is putting out water onto a warehouse. So with this situation, we do have a nice quadratic here. So we can go ahead and set up some x and y axes that will model our graph for us. From the information we know, we have the water cannon to the roof of the warehouse is 120 feet. So we know if this is our origin at 0, 0, that the coordinate point where the water hits the warehouse is 120 feet away. So we'll have the coordinate point 120, 0. We also know that the water shoots up 50 feet above the barrel of the water cannon. So we know the maximum height that this reaches is going to be 50. In order for us to set up an equation in graphing form, we know that the h and k value represent the vertex of our quadratic. We know that the vertex sits in the middle of our two x-intercepts. Therefore, in this situation, the x value of our vertex is going to be 60, since 60 is in the center of 0 and 120. Because our parabola reaches a height of 50, we know that our vertex will be the coordinate point 60, 50. We can use this to plug into our graphing form of a quadratic for h and k. So we will have y equals a times x minus 60 squared plus 50. Now we need to solve the a value of this quadratic. However, we don't necessarily know just from looking at the quadratic what it is going to be. However, we can use a coordinate point to plug into the x and y variables of the quadratic that we have modeled to the right. Unfortunately, we cannot use the vertex as one of the coordinate points we plug in to x and y, because if we plugged in 60 to x, we would have 60 minus 60 squared, which would give us 0, and then y would equal 50, which we already know that point exists. So we can either choose to use 0, 0 or 120, 0. For this example, I will be using 0, 0. So we're going to plug 0 into the y, as well as 0 into the x value. Keep in mind, 0, 0 might not always be a coordinate point on the parabola that you are trying to model with an equation. So just make sure you are using an actual coordinate point of the quadratic. Now we want to begin solving for a. So we will have 0 equals a times negative 60 squared plus 50. Negative 60 squared gives us 3,600 plus 50. In order to get the a all by itself, we are going to have to subtract 50 from both sides of our equation, giving us negative 50 equals a times 3,600. We will then have to divide both sides by 3,600. And so we're left with negative 50 over 3,600 equaling to a. If at all possible, we would want to reduce any fractions. So this one, we can actually divide both the numerator and denominator by 50 to get negative 1/72 equals our a value. Now that we have identified the vertex, so the h and k values, we have also identified the a value, we can go ahead and write the final form of the quadratic, which will be y equals negative 1/72 times x minus 60 squared plus 50. We also want to double check that that a value does make sense. So we do have a negative a value, and our parabola opens down. We also have an a value that is, the absolute value is less than 1, which means it's going to be a really wide parabola, which is true for our situation. So we do know that the a value is exactly where we want it to be, and we plug that into the a value in the graphing form along with our vertex that represents h and k. And there we have the quadratic that models our situation.